this laboratory we use lasers to trap and cool small clouds of atomic gases to within a millionth of a degree of absolute zero. And at these super low temperatures, essentially all the motion of the atoms has come to a complete stop. And you see really unusual, really fascinating behavior that reflects how nature behaves in this very strange regime of the ultra cold. We have lots of diagnostics for how to look at these atoms. So those all the lasers and the vacuum equipment on the optics table. Here are some of the measurements that we make of the atoms coming out in real time. We literally can take pictures of these atoms by shining a laser beam through the cloud. So this white pattern you see here is the background of the laser beam, and this dark splotch right here is where the atoms have absorbed the light. So it's essentially casting a shadow. And from how dark that shadow is and the size and shape of that shadow, we can learn about how the atoms are moving, how many atoms are there, and how the atoms are interacting. We have several experiments running in which we're using the laser beams to trap atoms. So optical tables are full of lasers and mirrors and lenses that shape the laser beams and direct them to where the atoms are trapped. We have lots of high vacuum equipment that evacuates all the air out of our chamber so we can introduce just the atoms that we want to study and not have them perturbed by interactions with any background gas. That allows us to trap and hold the atoms for tens or 20s of seconds, which is a lot of time for us to study their interactions or manipulate them in many different ways. My research group consists of about 8 graduate students, and in the summer we often have several undergraduates come and join our research as well. And they're all trying to study new things that will allow them to write research papers or write their theses and get their degrees.